Hey, today we are going to learn about R value and scatter plots on Desmos. Previously, we talked about this vocabulary. A scatter plot, as we know, is a graph in which the values of two variables are plotted along the axis. The pattern of the resulting points can be shown as a correlation. So we saw something and it might have looked like this. That was a great scatter plot. Correlation is a relationship between two variables. A linear relationship is a set of data that creates a line. Line of best fit is a line that best fits the data. Today we're going to explore that a lot more. We're actually going to have Desmos create the line of best fit. Equation of a line, as we know, is y equals mx plus b, where m is the slope, the rate of change in y divided by change in x. And the y-intercept is where the data crosses the y-axis. So our new vocabulary is linear regression equation. This is the equation of the line of best fit. So it's the equation that Desmos gives us or a graphing utility gives us. Linear correlation coefficient is R value. It measures the strength and the direction of a linear relationship between two variables. R value is between -1 and 1. As always, pause this if you need time to write down your vocabulary. Okay, so we're going to look at two different scatter plots and we're going to define them as strong or weak. We're going to talk about our R value. The first one to the left, if we look at it, it makes a straight line. Oops. If we look at the one on the left, it makes a straight line. This R value is very strong. It's a strong R value. And I would even guess R equals 1. I'm saying it's 1 because it's a positive slope and the data makes a line. Really, really easy line to see. This data on the right, I would call it weak. It's really hard to make a line of best fit. If I had to guess, it might be like something like that. So giving it an R value, it's definitely a positive slope, so it's positive, and it's 0.5. Notice both of these R values are between 1 and -1. R's are positive because it has a positive slope for these two examples. Let's really look at our R value now. R value is the linear correlations coefficient, describes the slope and its correlation. Numbers closer to -1 or 1 are considered strong or good data. So if it's -1, it's good data with a negative slope. If it's +1 or close to +1, it's good data with a positive slope. Numbers between -0.5 and 5 are considered weak or not very good data. 0 is considered no correlation at all. Notice all those values are between -1 and 1. Let's explore some of these. The first one, its R value looks like it's +1. I believe it's +1 because it makes a really good linear line. So this is +1 R value, and it's very strong. It's good data. Next one. Ooh, not so good data. But it's negative. So we know R equals negative because of the negative slope. And it's okay data. It's kind of close together. So I'd say -0.8 or 0.8. It would still be considered strong. Ooh, this next data. All I can see is it has a positive slope. It's pretty weak. Pretty weak data. But it has a positive slope, and I would say, about 0.5. Ooh, this next data, no correlation at all. It's just dots everywhere. No correlation. I would say r equals 0. And it's not even weak or strong. It's just no correlation because the scatter plot really doesn't show us a pattern. All right. I would like you guys to go through this. The correlation coefficients for the three scatter plots shown below are either negative zero point 0.4, zero point 0.9, 0.99. So match each scatter plot with the correlation coefficient. The next one. The correlation coefficients for the three scatter plots shown below are either negative 0.85, so pretty good, 0, meaning no correlations, or zero point 0.5. Match each scatter plot with the correlation coefficient. All right, we are now going to look at this problem. We've done many of these types of problems. Recently, Adam put large wheels on his skateboard and noticed it would coast farther. He decided to test this relationship and gather the following data. Notice how he gathered the data of his wheel diameter in inches and his rolling distance in inches. So if we look at this first point, his wheel diameter was 1 inch and his rolling distance was 19. The next point, 2 inches and his rolling distance was 23 inches. So we're going to find the equation of the line best fit, and we're going to round to the nearest hundredth. We're going to use Desmos for this. Then we're going to describe the real world meaning of the slope and y-intercept of the line. If Jimmy's skateboard had 8-inch wheels, we're going to approximate how far it will coast. Use your line of best fit to determine the size of the wheel of a skateboard that rolls 50 inches. Interesting. And what's the correlation coefficient? What does it mean regarding this problem? All right, we're going to go to Desmos.com. We're going to hit the button Graphing Calculator. Right now, I'm going to go through directions on how to do this. You guys can do this on your own with the next problem. So the first thing we do, Desmos.com, and we're going to hit the button Graphing Calculator. Hit this button right here. When we hit that button, we're going to see a graph and some numbered lines right here. We'll have 1, 2, 3, etc. I want us to start by hitting the plus sign. When we hit the plus sign, we get this table, these options. Select table. When you select table, we can start entering the points. We are going to put a 1 here and 17 for y, 2 for x, 23 for y, etc., etc., etc. All right. Notice when we do that, Desmos has graphed a scatter plot for us. Now we need to tell Desmos to please make the regression line. So in the second box right here, we're going to type the equation y1 squiggle m x1 plus b. Let's see what that looks like when we type that into Desmos. When we type this into Desmos, we have y sub 1, the squiggly as we put in, the slope m x1 plus b. M1 and x1 refer to our data points. Notice that we're given our r value right here. We're not going to worry about r squared until you take statistics. But our r value is what we're concerned about. Our slope is what we're considered about. And our b value is what we want to know about. When we do this, we are given the slope m and the y-intercept b. So our equation is y equals 5.32181 times x plus 10.5851. However, the directions that we were given said round to the nearest hundredth. So with rounding, we get y equals 5.32x plus 10.59. Please notice that M is our slope. Please notice that B is our y-intercept, just like we've been studying. We're given a correlation coefficient of R equals 0.9652. That means that this data is really strong. Look how close our data is to the line. That's pretty great. All right, now let's go and work on our answers. So recently, Adam put large wheels on a skateboard. We just did this problem on Desmos. And we found the equation that best fits our line. And the equation, rounding to the nearest hundredth, let's write this in a fun purple, is y equals 5.32x plus 10.59. Describe the world meaning of the slope in the y-intercept of our line. Okay, our slope m is 5.32. Sometimes I like to put it over 1 to remind me. 5.32 is change in y over change in x. So that means for every 1 inch in wheel diameter, it will roll 5.32 inches. Inches of rolling distance. So for every 1 inch of wheel diameter, your skateboard will roll 5.32 inches. Okay. The y-intercept is kind of silly. The y-intercept is 0.10.59. This basically says if you have 0 inches of wheel diameter, you're going to roll 10.59. Of course, that does not make sense. However, it makes sense in the context of the problem, is that's kind of where we start. So, if Jimmy's skateboard has 8-inch wheels, approximate how far it will coast. So we are given this equation, y equals 5.32 times x plus 10.59. Well, since our wheel diameter is 8 inches, we're going to stick that in for x, 8. So now I'm going to take 5.32 times 8, and I get 42.56. And I'm going to add 10.59, and we can estimate, using this line of best fit, that it will coast for 53.15 inches. It will coast for 53.15 inches. That's kind of cool. So now using your line of best fit, determine the size of wheel. So we're going to look for X now of a skateboard that rolls 50 inches. So Y is 50. So 50 equals 5.32. Now we're looking for the wheel X plus 10.59. All right. You guys might remember this from last year. So we're going to subtract 10.59 from each side. And we get 39.41 equals 5.32x. And we divide by 5.32, divide by 5.32, and we get x equals 7.41. So the size of the wheel needs to be 7.41 inches in diameter. So what's our correlation coefficient? Desmos kindly gave us our R value, and our R value was 0.9652. This means that our data is strong and positive. I know that it's strong because it's close to 1, and I know that it has a positive slope because it's a positive number. Sweet. All right, try this question on your own. Put it in Desmos. Ask your teacher for help, and answer the following questions on the Ed puzzle. Don't forget to go all the way to the end to get full credit. I hope you have a great day.